All right, so I thought I'd make up an example, and what I wish I was doing right now would be going to the beach. And here's our camper, and we would be, it's basically a truck, okay? But then there's this big old camper on top. Okay? So this is us going to the beach. Okay? And I'm going to make my number line my coordinate system, and I'll write position in miles, right? And this is home, and this is the beach right here. Okay? So let's say that these are dots, or where we're at every, I don't know, in equal time intervals. This dot is where we're at while we're driving to the beach. Okay? And then these dots down below will be the trip back from the beach to home. Okay? And if I did this right, these dots would all be equally spaced. It's not perfect, but it's close here. I'll fix a couple of them. They should be in the same spot, so I'll make them like that. There we go. And let's see here. So here's my velocity vectors. Okay. Those are supposed to all be the same length. And then here's the trip back. More velocity vectors. They're all supposed to be, again, the same length. Okay. And let's just say I'm going 30 miles per 1 hour. Okay, that's our average velocity. Okay. So we got the trip there, and we got the trip back. This would be called a motion map right here. This is a coordinate system that I defined. Oops. So I defined my coordinate system. And then now on the next slide, I'll do some graphs. All right. So I'll make a position time graph here. X, miles, t, seconds. And then below that, I'll do a velocity graph. So velocity, miles per hour. And again, time in seconds. Okay? And I'm going to draw a dotted line for this weird little time that I'm ignoring. See, when we go to the beach, we stay at the beach all day and then drive home. So you don't go to the beach and then instantly drive back, right? But we're going to pretend that for this problem. We're going to have the same exact slope. Okay. This part's a little messed up, so I gotta fix that. So I'll make this line go to there. There we go. That looks much better. Oops. All right. So we got the trip there. That's what this part is. And we got the trip back. That's what this part is. That's the trip home. Okay? And then if I wanted to draw a velocity graph, well, on the trip there, the velocities are positive. Okay, on the trip back, the velocities are negative. Right? And let's see here. Maybe I can use a different color here. Okay. So look at this area right there. Right? I'm going 30 miles per hour, and let's say it takes me like a third of an hour. And then this time over here would be like 2/3 of an hour, right? And then from here, 0 to over here, that would be my my change in position. So it's like over here, this amount here, right, is my change in position. Because I start at 0 and then I go to the beach. And then I go to the beach and come back, right? So let's talk about the trip to the beach first, okay? So on the way to the beach, I'll write that here, on the way to the beach, right? I'm going to call this delta x1, which is a displacement, right? And if I travel 30, see, what is that again? 30 miles per 1 hour, and that's times 1/3 of an hour, right? Well, hours will cancel, and I'll be left with 10 miles. And that's positive, right? Because my displacement is going to be 10 miles. And that's on the trip there. So that, I'm going to call that displacement 1. Okay? And then the trip back, maybe I'll do that in another color. On the way home, okay? So I'm talking about, I'm going to call this delta x2, and you notice that displacement, which is the same as, well, another way to find displacement is to take the final position and subtract from it the initial position. Well, if you look at this part, my position time graph, you're talking about 10 miles minus the 0 miles where I started. And that also gets you 10 miles. Same thing. Now, delta x2 would be my final position minus my initial position, right? Which is, my final position is back home, which is 0, minus my initial position, which was 10 miles, right? That gets me a negative 10 miles. Now, the other way of doing that, which is kind of cool, is just by looking at the area of my velocity time graph. So any one of these I can find, I can just use area of velocity, not position, versus time graph. And that works as well. Okay? So area of velocity versus time graph. And in this case, that's a negative 30, right? That's a negative 30 down there. Negative 30 miles per hour, right? That's, whoops. So I got negative 30 miles per hour times, and it's 1/3 of an hour again, and hours will cancel. And so delta x displacement on the way back is going to be negative 10 miles, right? Now, if I want total displacement, well, since I went there and back, and my ending position is at the same place as my beginning position, my final position and my beginning position are the same number, right? So it's going to be 0. which is 0 minus 0 is 0. Another way to do it is I can say that my displacement on the way there can add to my displacement on the way back. Well, on the way there, it's positive 10 miles plus negative 10 miles, and I still get 0 miles. That's for my total displacement. Okay? So let's wrap this up with average velocity and average speed. So if I want to talk about average speed, I want to use the total distance that I traveled, total distance traveled, right? And I want to divide that by the time elapsed. Okay, the total distance is going to be 10 miles plus another 10 miles and a third of an hour plus another third of an hour. Okay, and that's going to be 20 miles over 2/3 of an hour. And I can multiply the top and bottom of this fraction by 3. That's just like multiplying by 1, right? So I can multiply that, and this 3 here disappears, right? And I'm left with 20 times 3, which is 60. But then I got to divide by 2. So 60 miles divided by 2 hours. So that's going to be an average speed of about 30 miles per 1 hour. So that's my average speed, okay? Okay? Now, if I want average velocity, it's like a totally different story. Okay? Average velocity is going to depend on my change in position, and it's still divided by my time elapsed. My change in position is the same thing as my displacement. Which is my final position minus my initial position, and those positions are identical. And my change in time is the same as always. So, as you already know, your displacement, if you go there and back to the beach and back, your displacement's going to be 0. And it's still 2/3 of an hour, but the numerator of this fraction is 0. So 0 miles per 1 hour. 0 miles per hour. And so that's our average velocity. You could write that in symbol form like this. Okay? So clearly you can see that the total distance you traveled, average speed depends on the distance you travel. Whereas on the other hand, average velocity depends on your displacement, which is your change in position. Anyway, I hope that helps you out, and have a good day. Thanks for watching.